I hope my screen is visible to you.
Yes, sir.
Okay. Okay, then I will start today's class. So today we'll be looking at the manufacturing processes for polymer products. So I think that is the lecture which you have covered for this week. I will be explaining a few questions, so that will be helpful for you to solve your assignment. Okay, so we will start with the first one. So in the first question we have, what does the term gate refer to in injection molding? And we have the four options here. It's like, so we were just beginning the first question. What does the term gate refer to in injection molding? The first one, the options are the part ejection mechanism, the injection nozzle opening, temperature control system, and the mold clamping mechanism. So here we can clearly see that the term gate definitely must resemble something from where you're either entering the system or your polymer is entering the system. So the injection nozzle opening is what is called the gate. You can see the schematic right here, which is being shown. In this, you can see that how the polymer is being fed through the hopper right here, and then the screw is injecting it into the die. So you can clearly see the polymer which is being filled inside, right? So that polymer right here is the this part right here is called the gate. So that injection nozzle part is the gate inside the injection molding process. So you can see how the polymer is flowing inside the gate, and the polymer, once it is cooled down, it will form the shape and it can be ejected outside. Moving on to the next question. What is the purpose of the ejector pins in injection molding? So again, coming back to the same schematic, you can see how the polymer is entering inside the screw chamber and it is being injected inside the die. So once the product is formed, you can see the pins right here, three pins. These three pins are actually the ones which are called ejector pins. They are used for ejecting out the finished product. So you can clearly see how these push out the finished product. So that is the mechanism through which you are obtaining a finished product. So to assist in removing the molded part from the mold. So the mold can be of any shape, and the ejector
Is it a
pin,
second question?
yeah,
Is it a second question?
yeah, it's the second question.
Okay.
It's the second question. So that is how you are doing the ejection of your finished product. And your ejector pins can be in any shape or form, and they can be on the different sides of the mold depending on the type of mold which you have. And usually, the ejector pin is located in the part of the mold which is moving. So you can see that the front part of the mold is moving and the ejector pin is present in that one. And the down part of the mold is stationary. Ejector pin is not there because injection of the material is occurring on that side. So to assist in removing the molded part from the mold. Then moving on to the next question, we have which of the following statements regarding amorphous materials used in injection molding is true? So we have four options here. They have a highly ordered molecular structure. They exhibit a sharp melting point. They are more prone to shrinkage compared to crystalline materials. They have a crystalline structure with distinct melting and freezing points. So in the question, it is being asked that we have a amorphous material and injection molding is the process. So already we know that in amorphous material, the polymer chains are arranged in a haphazard manner. This haphazard arrangement, what it does is it creates voids inside between the polymer chains. You can also call it that the free volume between the polymer chains is higher. So this free volume, what it does is once you heat the polymer inside the injection molding process, and once the product starts cooling down, once it has been injected through the gate into the mold, what happens is uh, these uh, amorphous materials start to crystallize. Why? Because as the cooling is happening, the polymer chains are having enough time to arrange themselves into an orderly fashion. And this ordered fashion will remove all the free volume which is present inside the amorphous material. So because of this, For example, if you're injecting some amount of polymer, X amount of polymer, from that X amount of polymer, you will be removing the free volume which was present because of the amorphicity of the material. Since it will be slightly more crystalline, so what will happen? They will be more prone to shrinkage. Since it was amorphous, and once you heat it and again cool it down, the chains will arrange themselves in such a manner that your free volume or any empty spaces between the chains will reduce. And because of this, your product will start shrinking. And this shrinkage, what it will do is sometimes if the shrinkage is not proper, it will warp the material. Warp the material means if you're trying to make a flat plate, for example, if you're injecting from one side and your mold is creating a flat plate, your flat plate comes out, and if the shrinkage happens, the plate will bend by itself. Why? Because it will be shrinking in some uneven places, and because of that the entire plate will bend. So that kind of problems can occur, and that is exactly the reason why they are more prone to shrinkage compared to the crystalline materials. As we already know that crystalline materials have ordered arrangement. So so the crystalline materials have ordered arrangement, and because of this the shrinkage is very less in case of a crystalline material, because already they had low free volume, and once you heat it and cool it back again, they are actually returning back to their own uh, same shape. So the shrinkage is less, and as a result of the less shrinkage also, sometimes warpage will also be low. Moving on to the next question. For all the students who came later, I will be reciting the questions one and two again after I finish this cycle first. Then in the next question we have, which of the following factors can affect the extrusion process? So here is a representation of an extrusion of the polymer, as you can see right here. So we have the hopper and we have the polymer going inside. Then we have the screw and heated jacket is present right there. So what it will do, it will start melting the polymer, and the screw is rotated so that it will push the polymer in the front. So basically we are charging the polymer, and then through a steel die of various shapes, what it will do, it will forcefully push the polymer material, and your extruded product will be then cut out. Okay. So here, what are the parameters through which we can basically control the extrusion process, or what are the factors which can affect the extrusion process? So we have the options right here. First of all, temperature. So if we were to increase the temperature of the heated jacket or decrease it, we can increase or decrease the response to the temperature of the polymer itself. So if the temperature is low enough, what it will do, the polymer will be more thicker and it will be more difficult to process it through. And if the temperature is really high, the polymer might sometimes it might go to like it will be heated a lot and the viscosity will be really low. And because of that also, sometimes complications can occur. Next, we have the screw speed. So the Archimedean screw, which is being shown right here, uh, the rotation of the screw itself is the rotation speed of the screw itself is actually a very big controlling factor in the polymer extrusion. Why? Because if you were to spin the screw really fast, polymer can heat more than what the heated jacket is applying the temperature. Why? Because as the screw is processed through the hopper by the screw, what happens is viscous heating. Because of the viscous heating, the polymer heats up as it is going through the Archimedean screw. It will take some time to understand. As you can see that the polymer is entering from above inside the hopper, and you can see that when it is passing through the screw, because of that rotational movement, polymer is being stretched. And since polymer is viscoelastic, and we already know that it has viscoelastic properties, that kind of stretching motion can create a viscous heat dissipation phenomena inside the polymer, because of which the heating can occur. So that's why screw speed is also very crucial, and it has to be controlled so that overheating or any kind of other phenomena should not happen with the polymer. So the first two factors definitely affect the extrusion process. Then we have the die design. Now, we have the die design. So die design basically what it does is that if the die is small enough or large enough, it will control the volume of the material which is coming out of it. So it has to be in such a way that the amount of volume present uh, before the die, that is inside the screw, and what is the amount of material coming out, should be in such a way that there is a continuous flow and no accumulation is occurring. Why? Because if accumulation is occurring, definitely heat will be built up. Why? Because the screw is continuously spinning. So because of that continuous motion of the screw, even more heat will be generated if the steel die is not big enough. So the die size also and the die design also affects the polymer extrusion process a lot. Then fourth one we have is the polymer viscosity. Now, polymer viscosity, basically the polymer which we are supplying inside, what will be the viscosity of that? That also affects the polymer extrusion process because if the polymer is highly viscous, it will take a lot of resources to heat it up and to send it through the extrusion chamber. So it will take a lot of effort to send it through the extrusion chamber. So So the first four factors are definitely affecting the extrusion process. Now, the last one is the ambient humidity. Now you can clearly see that this is a heated screw design and we have the Archimedean screw. So basically humidity does not have a role to play in this. And you can see that there is no like, way to explain or any way for the humidity to affect the process in itself superficially or in any major manner. So that's why the first four options, that is temperature, screw speed, die design, and the polymer viscosity, are the major factors which are responsible for the polymer extrusion process. Next question. Which materials are commonly used in the injection molding process? So we have been given five options: ABS, polyethylene, polypropylene, glass, and steel. So definitely you can see at first glance itself that the first three are polymers, fourth one is glass, and the fifth one is the steel. And we know that the uh, reason we use injection molding process is for the thermoplastic polymers. And clearly, the first three polymers, that is the acrylonitrile butadiene styrene, polyethylene, and polypropylene, all three fall into the thermoplastics category. So that is the exact reason why they are used in the injection molding process, and they can be molded using that because we simply apply the heat and they can be injected through a certain die and your product will be formed. Then we have the last question. The channel that connects the injection nozzle to the mold cavity is called what? So you can see that there is that small channel which is connecting the injection nozzle to the mold cavity. You can clearly see inside this. I'll just increase the illustration. So you can see that the small space which is present right here. So that space is actually called a runner. What does runner means? The word runner suggests, like what we can understand from that is that the polymer is running through that place. So that is exactly how the material is entering from the hopper, going through the screw, and it is running through that runner to the mold cavity. So the cavity which forms when the front mold comes into place, and the polymer which is present inside the screw will go through that small space into it. Okay, and runners are also present inside the polymer to spread polymer molding process to spread the polymer in different directions also. So that can be observed in sometimes compression molding also, or the compression molding and injection molding, which is and sorry, in compression molding we have something called vent. The the job of the vent is to actually remove the excess polymer, which can sometimes be injected during the compression molding process. But this small injection nozzle right here is called the channel is called the runner. So I will go back and explain the first few questions for the students who joined late. So again, I will explain now. What does the term gate refer to in injection molding? So the injection, clearly the answer for this is the injection nozzle opening. So in the injection molding, you can see right here that the injection nozzle opening, right where it is starting to open up, that is called the gate of a gate in the injection molding process. Next we have is what is the purpose of ejector pins in the injection molding process? Now clearly, as the name suggests, ejector pins means they are used to eject any kind of part. So the finished product, which comes out after the uh, injection molding, is ejected out. You can see the three pins right here in the front mold as the polymer fills up the product inside the mold. And once the polymer cools down, it is pushed outside by the three pins, and it can be seen in the illustration clearly. So to assist in removing the molded part from the mold is the job of the ejector pins. Next, we have which of the following statements regarding amorphous materials used in injection molding is true. So we have been given four options here. And first of all, the amorphous materials, when they're heated during the injection molding process, when they're passing through it, what happens in that case is that the amorphous spaces which are present inside the polymer, they will start decreasing first of all. Why? Because when you heat the polymer, all the free volume which is present inside, the chains are first of all free to move around. And once they are free to move around, they will occupy any random shapes. But once you start cooling it down, the chains will again compress back into their into a more crystalline manner. More like they always occupy the places where empty space is there. So in amorphous material, already a lot of empty space was there. So once you heat it and cool it down again, the free volume which was already present there, it might reduce. And because of that reduction, the material or the product is prone to shrinkage in comparison to the crystalline materials. Why? Because in crystalline materials, already that free volume or the space was lower. So anything lower than that won't affect the crystalline material as much as it will be affecting the amorphous material. So in case of the injection molding, the amorphous materials are more prone to shrinkage compared to the crystalline materials. The next question is, which of the following factors can affect the extrusion process? And we can see the illustration right here. We can observe the different factors which definitely affect them. First of all is the temperature. The heated jacket and the screw itself can impart temperature to the polymer itself, and that in turn affects the viscosity or the speed at which the polymer will come out of the steel die. So temperature is definitely one of the factors. Then screw speed, as I said, the screw speed itself can cause the viscous heat dissipation of the polymer. And because of that, the uh, the rate at which the polymer will come out of the die will also vary. So that also affects the extrusion process. So if we want to have a continuous process where a certain X amount of volume or the material is coming out of the steel die, it is better to control the screw speed also. Then the third one is the die design. Now, in die design, as I said, if the die size is too small or too large, the amount of polymer which is being dispensed outside as a product can vary, and that might cause the heating issues inside the uh, screw extruder itself. And then we have the polymer viscosity, the first and foremost property which affects the polymer extrusion process. Why? Because if the polymer is highly viscous, you might need to have higher screw speed or the heating should be applied higher so that the polymer melts down enough that it can be passed through the screw. And if the polymer viscosity is quite low, the sufficient amount of heating can be done by the viscous heat dissipation itself, and heat jacket won't be that much required. So, polymer viscosity also affects the extrusion process. Ambient humidity does not play a role because, first of all, it's a closed system right here, and the humidity does not have any role to play inside the screw extrusion. And we have seen this question right here that which materials are commonly used in injection molding. So the first three options are definitely thermoplastic polymers. And thermoplastic polymers are usually melted and injected into various shapes. So the first three, ABS, acrylonitrile butadiene styrene, polyethylene, polypropylene are the correct answer. And the last one, the injection nozzle mold cavity is called the runner. Basically, because the polymer is running through that space into the mold cavity, and that's why it's called a runner. Uh, I hope I was clear, and if you have any doubts, you can ask me. These are the
So
only questions. Yes, yes,
can
ma'am.
you explain about the common defects that is occur in injection molding?
Hmm. So what happens in injection molding is that sometimes the sink defect will also come into place where the sink marks can occur. And in the finished product, sometimes the sink marks are present where if the polymer has not spread properly or if there is some kind of space left outside. So because of that, the sink marks occur. That is one type of defect. Other is shrinkage. Definitely, we just discussed about it. So shrinkage is the one where your material can shrink after cooling down, and that will cause a defect called warpage. In warpage, what happens is if there is uneven shrinking in different parts of your product, the different parts of the product will shrink in different manners. And because of that, the alignment of your product can change. It can either bend upward, downward, or in weird shapes. So that's why we have to make sure that the shrinkage of the polymer material also is being controlled. And the material which we are supplying inside the injection molding process should also be controlled. And how the properties behave is very important to control. So these were the few defects: shrinkage, sink marks, and warpage.
Will it be? Will there be any delaminations if we are using different materials in
Uh, Delamination won't be there, I guess. No, delamination won't be part of polymer processing at least. I think so.
so the two more options are flash and oxidation.
Hmm.
So
Flashing is something which occurs in this thing, compression molding. What It's not a defect, it's more like it's a part of the process itself. What happens in compression molding is you already have your polymer present inside the mold. Your compression mold comes from the top, it squeezes it down, and the excess amount of polymer which comes out from the sides is called flashing.
okay,
Yeah. And oxidation is something which it's a chemical phenomena and not exactly dependent upon the processing of the polymer. So that
okay.
can occur or not occur. It depends.
And one more question also I have. Which of the following is a primary advantage of injection molding? I have
Hmm.
given high production flexibility,
Yeah.
and I also have a doubt with uh, minimal maintenance requirement also the advantage.
Yeah,
So,
I mean, the maintenance requirement is quite low because once the screw starts spinning, you basically don't have to do anything. You have to just supply the material at a constant speed. So that is one thing. And
so primary advantage may be high production flexibility or minimal maintenance.
yes, because flexibility is there. You can, if you
Okay.
want to increase the production, you can increase the speed of the screw or the way it is being fed inside the, like way how the material is being fed. So that's how you can control it. So there are many parameters you can change. Either increase the heating jacket temperature so that more polymer material can be dispensed outside. So you can change that.
Okay. Kanchana, Kanchana, he is AC Tech student only. So she is another faculty from our department.
Oh, okay. No, ma'am.
Kanchana, are you there? Thanks.
Ma'am, are you conducting, like, you're attending this course from department itself right now?
Yeah, not from department, but we have got permission from our registrar.
Okay, okay.
Hello, Rohan. Nice to know that you are a tech student. I was not able to unmute.
Oh,
Touch
okay, okay.
problems.
Okay.
So
Yes.
he helps us a lot, Kanchana.
Hmm.
So he is helping us to clear other
Doubts
uh,
also.
yeah options which is not relevant. So that's why I
Mm.
feel very clear.
This course is very useful, very in-depth explanation.
I asked him to come to the department. I invited him to the department.
Yes, we can arrange a guest lecture with our students.
No, no, he said he
Mm.
cannot do that. So he'll
Oh,
just meet the student.
okay, okay,
We'll just ask them to meet the PD student.
okay, okay.
Nothing to do, but we meet them.
Ma'am, I think I will be able to visit the college on Monday, next Monday.
Next Monday is a holiday. Oh, no, no. It's Ramzan or what? Some function.
Uh,
The government holiday shifted to Tuesday.
Oh, shifted to Tuesday.
Mm.
So
okay.
probably we are going to TNPC for some
Oh,
other
okay,
Oh,
okay.
confidential
oh,
work. So we are not available in the department. So only
Okay.
on Monday you are there.
Saturday, like I'll be coming on Friday. So
Oh,
Saturday, Sunday. Yeah.
so Monday I'll be waiting for you.
Okay,
Maybe
ma'am.
10 o'clock we can meet.
Yes, ma'am. Sure.
Thank you. Thank you.
Yes, ma'am.
Kanchan, you have any doubt, Kachna?
no, no. Thank you, thank you.
Thank you. Thank you, Rohan.
Yes, ma'am. Hello.
Hello.
Yes, ma'am.
It's almost perfect, but you know, I will ask you to change it a little more, I guess.
Uh, yes, ma'am.
Okay, so is it possible for you on just to start detailing or to have
Right now, actually, it's fast. So, like, I will come online at 7:15 or something.
yeah, anytime. Not much work.
Okay.
I'm changing policy for you.
Yes,
I'm going to go to that work with the answer and what I'm talking about. Just I want to download your a little bit sophistication that you.
yes,
And also I think okay, I talked and that time only all I talked to our project also.
yes, yes.
I don't know anytime very bad time. I'm not going to get back to 9 o'clock. Which I have to complete before 9 o'clock, but I have to go for dinner at 9.
Yes, sure, sure.
So take your time, organize, send me a link, and I'm sending my modified one. Okay.
Yes. Okay. Oh, yes. Yes. Hello, hello.